I'm a data analytics SME. I wear several hats at Google. One of them is data analytics SME. I work with the upcoming products and I contribute back to them as well. I also have a sales hat on, so I'll end up working with a lot of payers and providers in the industry, helping them with their data platform modernization with Google Cloud. So today's presentation is broken up into 3 parts. The first part is about the Google Healthcare Natural Language Processing API. I'm going to give you a brief overview about what this API is. The second part is about mapping this API output to FHIR. I don't know how to get rid of that thing because it's not on my screen. Anyways, so carrying on. So the first 2 parts talk about the natural language processing API, mapping it to FHIR. And the third part builds upon the first 2 and brings together how these things can be leveraged at scale, at volume, actually getting you an entire end-to-end data pipeline from paper to FHIR, paper to insights. Thank you. All right, so first things first, let's talk about the API. As most of you know, there's a lot of unstructured data in healthcare. Some statistics say that about 80% of data in healthcare is unstructured in nature. And my personal take on the subject is this. There's a whole bunch of structured data in healthcare, and I think the industry has somewhat learned to deal with it. I'm not saying it's perfect. I'm not saying it's all figured out, but people have figured out how to deal with it, have understood the pitfalls in it, and they somewhat have a roadmap of how to kind of get it in the ideal state with FHIR R4, etc. Right? That's not the case with unstructured data. A lot of my daily conversations today is about helping my customers work with unstructured data with a simple goal. What's the goal really, right? Like, how do I get every insight out from my data that can add value? How do I get every possible value squeezed out of the data I have? And there's a lot of unstructured data that's left on the table, which is not being leveraged enough. So that's the goal. What's the business goal? Okay, how do I have better outcomes? First of all, how can I improve outcomes for my patient? How do I improve outcomes for the research industry? And how do I get better outcomes for the business entity in question, who's the custodian of the data? So overall, this is just a little picture of some examples of the sources of the various unstructured data: consumer reports, medical notes, lab results, scientific literature. So what the Google Healthcare API does, it's able to pull out from a blob of clinical text 4 categories of information. And I'm going to kind of double click into each category in the next few slides. But these 4 categories are the knowledge extraction and the knowledge entities, being able to extract clinical entities from blobs of clinical text, building out, creating the relationships and discerning the relationships between these extracted entities, context assessments, and knowledge linking. And I'll kind of go through each one of them. The first one being knowledge extraction. From the medical text, this API is able to pull out things like medical conditions, procedures, anatomy, medical devices, etc. Right? This 25 categories supported documentation has an entire list. Now, if you're wondering, there's plenty of vendors out there who have this feature. You're possibly right. And that's where the next feature comes in. And this is pretty unique to our API, being able to determine relationships between the extracted entities. For example, medical device related to what part of the body, medical condition, which device is associated with a medical condition, which medications are associated with that condition, procedures and relationships, medications and relationships between the various medication-related entities, right? The next thing being context assessment, right? You got the entities, you got the relationships between the entities, but who does this stuff, who does this extracted stuff apply to? Does it apply to the patient, to a family member of the patient, to somebody else? And all of this becomes important for the situation at hand. For example, becomes important for something that's genetic in nature or infectious in nature, just to give you an example. What's a temporal assessment from the clinical note? Is it current? Is it something part of clinical history, family history? Is it something that's upcoming in the near future, or it's still something else? What's a certainty? From the natural language, the API is able to figure out from nuances in the language, what's the certainty of the entity that's extracted? Whether is it likely, conditional on something else, somewhat likely, or not likely at all? The last part is also really interesting, and it really becomes interesting from a data analytics point of view and a data interoperability point of view. So 17 supported vocabularies. And what this does, what this portion of the API does is from the extracted entities, it's able to map it out to standard vocabularies. So for example, as you know, the healthcare community uses multiple words for referring to the same condition. What this does is standardizes on the vocabulary. So allowing you to kind of search. So once you have all of this unstructured data converted to structured, allowing you to search through and create insights based on standard terminology. So let's see it in action before we move forward. So this is an example of what this is an example of a clinical text blob. And what I'm going to do is when I click the run button, it's going to be throwing this text blob at the API. It's a REST endpoint, and it's going to create do all of the entity extraction. Right? It's an example of the entities extracted. So first one, COPD. It's identified as an entity type of problem. The context assessment is it refers to the patient. It's likely. It's a current condition, and it gives a confidence score. Given it's a machine learning algorithm, it has a confidence score for every piece of the entity extracted, every relationship that's extracted. The linked entities refers to the standard vocabulary you kind of mentioned. And there's a whole bunch in here that's it's mapped to. Similarly, exacerbation is identified as entity type of severity with standardization in the form of linked entities. Satting is identified as a body measurement. Hopefully you get the picture. So this is with respect to extracted entities. Let's look at the relationships, right? So this is, in this case, it's able to associate entities of severity and the condition. In this COPD with exacerbation, it's able to associate satting with the numerical percentage score. For example, a medication is able to identify a medication named albuterol along with the various other entities extracted relevant to the medication with respect to number of puffs, administration, frequency of administration, and the list goes on. From a developer perspective, this is what it looks like. This is a REST endpoint. This is the request payload contains the text blob, and the response is a massive JSON structure. Now, as we move forward, I kind of show you how you can persist this JSON structure and how you convert this into FHIR. By the way, the conversion to FHIR is a feature that's going to be added to the Google Cloud API. Going back. So I'm not going to spend time on this, but this has a nice link to how this API compares with some of our competition. I'm going to switch gears. This next section talks about an approach that's taken to map and represent the NLP output in FHIR. So overall, this is a very, very high level diagram. Hopefully it's visible, but on the right-hand side here, there's going to be a single instance of a device and a device definition. The device definition clearly calling out that a machine learning entity, Google Cloud Healthcare NLP API, is a player that's generating the insights. The device is merely an instance of the device definition. This is all standard FHIR resources, right? So there's expected to be one instance of a device and device definition. And the left-hand side, you see the various resources that are created as the output of the NLP API. So on the left-hand side, you'll see 0 or more resource types of, say, condition, procedures, medication statements, just as examples of the kind of resources that are created. The one thing that's common between the three types of resources that refer to like patient condition, etc., is they all point to a document reference. And I'll kind of go into that a little bit more detail. So they refer to the document reference as pointing to the source of the derived entity, as well as more detailed information on how the entity was extracted from a document. Along with it, there's also a provenance resource, which ties together the generating entity, which is the device, as well as a generated entity, being basically representing who created, which is the machine learning algorithm, the what that was created, that is the various FHIR resources, that is the condition resources, etc. On the extreme left-hand side, what's expected is sideband information with respect to patient identifiers as well as date of occurrence, which are expected to be fed into this API or utilized along with the results of the API to have your entire picture, to be able for complete representation in a FHIR repository. This is a little snapshot of what the device and device definition look like. As an example, for example, here in the device definition, an example of how I would represent the Google Cloud NLP API as a generator or a player of creating these insights. What I skipped in this picture is this part, which is the extensions. And I'm going to go into how I'm using extensions in representing the output in FHIR. So I have two categories of extension. And the reason why I'm using extensions is basically there's aspects, there are outputs in the API which don't have a clear spot in the standard FHIR resources, right? So I mean, when there's something which I can't represent clearly in a FHIR resource, that's what I'm using the extension for. So there's one standard extension and there's one custom extension and a couple of custom extensions I created. The standard extension is in line with the 34475 addendum, which basically talks about how the reference to the source document is to be made. So this is just a little snapshot, and I'll kind of go into it a little bit more when I kind of show the entire bundle that's created from this API. So it's very simple. It has a pointer to the document as well as an exact offset into where a particular entity might be derived from. There's a few custom extensions that I use. The first one being for the purpose of reporting the confidence score of a given entity. That's the first one. The second one being communicating temporal relationship. For example, something that might be upcoming doesn't seem to have a clear place to land in a FHIR resource. So my approach has been to communicate more, put as much information as possible rather than leaving it out. So put the upcoming sort of information as part of an extension, put the likelihood of the machine learning certainty assessment in the extension as well. There's some things, especially with respect to medications. For example, if a clinical note has something like switch the medication, I kind of put that information here as an extension, just as a fallback in case it's useful. Overall, summary of this isn't advancing for some reason. Okay, it's lagging behind one. All right, so this is an overall bundle example. For example, here I have this bundle could contain 0 or more resource types such as condition, procedure, medication, assessment. I have the resource type identified. I have the meta information included, that is the Google Cloud Healthcare NLP API. I follow the 34475 addendum, which has the document reference. The linked entities from the Healthcare NLP API are used directly as part of the codable concepts part of the resource. And I have the provenance, which talks about, which ties it together, the device and the resource itself. There's a quick example of the kind of input you would throw at the API and the kind of bundle you would see. Again, this is, I'm sure you're already familiar with bundles. So again, this is just kind of taking home stuff that I already discussed previously. Just an example of a bundle that's created, which has, it has too many resources in here, but just to show you, this has a condition, a coding information from the API, category, subject information. This comes from the sideband information I kind of referred to before. And the coding information derived pretty much plugged in from the linked entities of the Healthcare NLP API JSON output. All right, so I'm going to be pivoting to this third part, which is actually putting all of the previous stuff to work at scale and in a kind of a easy automated fashion, right? I understand, like, as part of my job, just having the APIs and the results is awesome, but having the rest of the ecosystem to kind of build that end-to-end journey is also critical. And this next section talks just about that. So things to consider when we're kind of trying to utilize this at scale, because it's not one or two documents you're dealing with, it's going to be tons of documents. Things to consider. What's your starting point? Is it a PDF, image, text blob? Because that would help dictate the kind of things you would need in your data pipeline as precursors to the main NLP work, right? Who are the consumers of the output? For example, are they business users or are they clinical systems? In most cases, my experience has been it's both. So it makes sense to kind of persist that output into varied systems and different systems to make it easy for the various personas involved, easy access of data. What's the kind of automation you want and the scale you want? And there are other tool choices that you can make based on those answers. So the first point, I'm going to talk about scale. So what I showed you was the REST endpoint, and you had the payload and you had the output. Chances are there's going to be thousands of documents that you might need to have to run through that API in a batch mode or in a streaming mode. For this purpose, I have one pattern which is documented in this link here, and I think when you access the PDF, you can access the link. This pattern talks about using Apache Beam, which is an open source programming paradigm for building data pipelines. Apache Beam at work to kind of ingest these clinical notes at scale and run through this job, call the REST API, and persist the data in BigQuery. So the sample pipeline linked to in here. This is not, by the way, this is not the only way you can do it. Depending on the scale, depending on the volume, you could use data flow. Depending on whether you want batch streaming, you could use data flow, but there's plenty of other serverless compute options also, like in the form of cloud functions, Cloud Run, that you could also put to work. But this is one example I chose. Second thing, starting point. What's your starting point? If your starting point is a PDF, chances are you need some sort of document AI, some sort of document functionality to be able to extract pieces of information out and just pass through relevant pieces of information through the NLP API. So in this case, I have an example where I start with a PDF. I run it through Google's Document AI. I have, you could, if you're familiar with Google's Document AI, great. If not, I'll just give you a very high overview. There's one version that's been available for a long time. It's the API, which you could kind of just throw your PDF at and get a return object in the form of key value pairs. But there's another document AI product that's come out, which allows you to create your own custom machine learning models to be able to build a machine learning model to extract pieces of information from your set of documents. So you might want to have a pre-processing pipeline in the form of document AI to pick out pieces of information before you pass that information into the NLP API. So overall, putting it all together, doesn't want to, okay. So this is an example of an automation, end-to-end automation I kind of put together. I use cloud functions for this example, but as I said, you could use data flow as well, or even other products like Google Data Fusion. So for some reason, okay. So this is an example of a starting document. This is a PDF. This has clinical notes or a provider reference sort of document. This is my starting point in this situation. I pass it through document API, the document AI, and I have an intermediate document. As I mentioned, this is an oversimplified example, but you can totally scale it up to more complex uses. But in this case, I have an intermediate document where I extract only the clinical notes as I'm highlighting here. I pass only the clinical notes through the healthcare NLP API, right? Now, as soon as I pass through this, I have the option of persisting it in BigQuery. So what am I achieving by putting it in BigQuery, right? What I'm achieving is the ability to run SQL queries on it, which is great. And along with being able to run SQL queries on it, I also have the ability to slap on a dashboard, like I'll show you in the next few minutes, slap on a dashboard like a Looker dashboard to kind of have your insights on a patient level granularity or a patient cohort level granularity, just as examples. So this is going back to BigQuery, just an example of what it looks like Okay, this is an example of how data is persisted in a structured fashion from the results of the NLP API. I haven't yet gotten to the FHIR piece. So here the data is in BigQuery, but I also put the data in a FHIR store. And this is an example of how it would look like in the FHIR store. So this was also covered by Dharmesh and Bob's presentation yesterday in the evening. This is an example of the Google Healthcare API, which has a fully managed FHIR store. In this case, I've already persisted the results of the NLP API in here. And this is an example of a condition resource that was created by the API and persisted here. So again, just kind of pointing out, so you have two sets of data, like one is in BigQuery, one is in Firestore as options, like for you to pick based on what your requirements are. All right, so far what we've done is started with PDF, extracted some pieces of information from it, run it through the NLP API, persisted the data in a data warehouse, persisted the data in healthcare API / Firestore. The last part, what I'm going to do is the so what, right? Now I have the data in BigQuery. I have the data in Firestore. There's two ways of being able to derive insights from it. So now the FHIR data itself in the healthcare API, like what was mentioned yesterday, it already has a near real-time sync with a data warehouse that's fully managed for you. So either you consume this data in the Firestore using FHIR APIs, or you can still run analytics on the near real-time synced BigQuery store that's in sync with this Firestore. Anyways, so that's two options there. What I'll show you is a quick dashboard that's possible to do with the data sitting in your warehouse. So this is an example of me showing you, hey, I've got all of this NLP results in BigQuery. I've got my dashboard, and I just want to search for how many of my records contain this word COPD. I just pick COPD here, right? And what this dashboard tells me is how many patients, what are the terms that contain COPD? In this case, there's three variations of phrases that contain the word COPD. And again, there's information on how many observations, how many related patients, how many mentions of that term were there. There's also a little list of the top current problems, likely medications, clinical history. This is just to give you an example of the kind of dashboards you can build on top of your extracted insights. Another version of it, which is more patient-centric, is, so the previous one was more like cohort-centric. This one is more patient-centric, allowing me to kind of take a clinical note and be able to build a quick dashboard for a particular patient saying, okay, and get a view of what is the history, what are the current likely medications, current problems that this patient has, and also kind of join this data with other information to be able to throw up other statistics like, okay, for such a patient, this is the average length of stay. So all of this, working towards enabling better patient care, better patient outcomes with the use of leveraging unstructured data. So overall, kind of summarizing what we just did, we went through the results of the Google Healthcare NLP API. We went through an approach of how this is mapped to FHIR and persisted in FHIR. And we talked about the ecosystem around it in the form of document AI, as well as scalable data pipelines to be able to consume some of this technology. This is some of my contact information. Feel free to reach out. A special thanks to the extended Google team that helped review and validate stuff as I was going along this. Other sessions that are going to be happening and have already happened here at FHIR DevDays this week. So that's all I had, and I would love to kind of address any questions.
So are there any questions from the audience here?
Hi. Actually, great work. Thank you very much for this presentation. A couple of questions over here. Is there any assumptions in the market that we are using in order for us to consume this data. There's some standards that are modified based on market. For example, you can have ICD-10 and AM, Australian modification, or things like that. Are these taken into consideration, or it just works out of the box on any standard that you have?
So, so let me understand what you're asking. I think you're asking about the coding systems that are used. So, the Healthcare Natural Language Processing API in itself has a linked entities, and it supports 17 vocabularies. So the mapping to FHIR doesn't make assumptions. It pretty much takes the vocabularies that are spit out and puts all of them, all the linked entities as part of the FHIR resource.
Okay. The modification of vocabulary, does it need to be loaded, or it's the 17 are the one that are identified by Google right now? And
so right now the 17 supported. I'm not sure if there's a plan for having a modification on those vocabularies, but I do know there's plan. They keep adding more vocabularies. Right. They keep adding more support for additional libraries.
Right. So if you deploy this in Australia, for an example, or in Canada, there is a modification to the standard terminologies that you're using. And I just wanted to know if it's applicable to this market, or this is just US market for now.
I don't know. I think it is you. I can take that offline. Okay. I can get back to you on that.
Okay. The other thing is the translation that's happening. It's just happening on the plain old FHIR specs, or there's implementation guides that put into the picture as well into that.
So for now, it is. So this is all work. This is fresh off the press, right? This is work in progress. So that's what even the 34475 is still work in progress. It's not set in stone yet.
Okay.
Part of this whole process is kind of get some adoption and get some feedback and plug in the gaps.
Okay, thank you.
So I love seeing the extension that shows the confidence on the resource itself. And I noticed that you linked to the device through the provenance. Are there other indications on the actual resource that it's come from NLP?
So I did two things just since I felt there was divided philosophy on using the provenance or not. So I have put a little bit of redundancy by using the meta field of the resource that calls out Google Cloud, NLP API, as well as the provenance, hopefully addressing different usage styles.
Thank you. Yeah, no perfect answer, but that's good.
Hey, thank you. Great presentation. Just, sometimes we talk about like the patient's story and like how, data can tell part of that, but sometimes the narrative of like goes beyond just the data. And I'm wondering, as you're doing your kind of NLP processing, if you're ever able to kind of call out like, yeah, we process this, but it really should be read in kind of the full context, or like the narrative is actually important it's important to extract the things, but seen in the context of what the clinician actually wrote. Is there any kind of way to tag that, or have you thought about that?
Well, great question. I think these are all steps towards getting that entire patient story. So quite honestly, from a developer leveraging and consuming the API, I only have information on whatever the text blob is that was sent to me, right? And I can do the best I can do with that text blob. But to your point, there needs to be a surrounding ecosystem that can pick up the text blob and put it somewhere. But the API itself can do the best job it can, and you do have dependencies on other players in the ecosystem. But it's a great point. I mean,
yeah, no, it's not an easy problem.
Yeah.
Thanks for an excellent presentation. I was wondering if you could talk about some of the most common use cases that we're seeing right now for healthcare NLP.
A lot of interesting use cases. So, and I hope I can remember all of them, thinking on my feet. But one of them is just patient care, a transfer of patient care. So I'm seeing a lot of cases where there's paper documents, where there's transfer of patient care with diagnosis codes, clinical notes, provider information, And a lot of customers in the field are trying to just automate that from paper to automate it out of paper. And what I'm seeing blowing their minds away is like, not only are they able to convert it from paper to like extract it from paper, but also to run NLP. So I'm seeing a lot of use cases where the journey starts with paper and they couldn't believe they could use NLP, but they're kind of exploring NLP. The second one is clinical notes, plain old clinical notes, being able to convert thousands of pages of clinical notes to some sort of insights. And again, even in that case, I'm seeing a lot of journeys starting with paper. Those are the most two very common things that I'm working with all the time. Claims is starting to get a little bit more attention, where clinical notes in the context of claims, people want to pass that through NLP as well to kind of reduce the burden on human processors. Does that help?
Great presentation. So my question is like, if there's structured data that's coming in the form of, let's say, CDA documents, and there's unstructured data, how do you collate all of that and still get the clinical insights out of it?
Yeah, so as I was alluding to before, right? So this API is what it does. It kind of takes a text blob and it converts it to insights, right? And the world of this API starts and ends with just the text blob that it has access to. And as part of the sideband information, to be able to actually persist the FHIR bundle in a FHIR store, you would need to have the patient identifier as well, as along with like things like date information, etc. Right? So my expectation is that when you put this generated FHIR bundle in a FHIR store, there is some stuff in the ecosystem that you need to kind of get the patient identifier to be able to persist it in the right place in the first place, right? So that's what you need, and I expect that the story should come from the FHIR store that has its other structured information flowing in, as well as this FHIR bundle making it in there. So you do need there's a little ecosystem that's assumed, because if you think about it, you're going to need to have the FHIR bundle put somewhere, right? And your source is likely going to be, like you mentioned, from other structured sources as well as unstructured.
Thank you.
Thank you. Great presentation. So is the intended use specifically for like clinical settings? Would this work for, say, like a document describing like a public health campaign? Like, would the NLP be able to process language that is more broad? Maybe like, I don't know, there was like a grassroots campaign, be able to process that type of language?
The expectation is yes. It should be able to work on clinical literature as well.
Thank you.
Yeah, thank you for your presentation. I was just curious if you can provide like any insights on like how people are using the confidence score in real life. Like an example I'm thinking is like patient safety perspective, or like, you know, is there like a kind of interval for being able to fully trust, you know, the output, or is there, you know, just there any insights you can provide there on how people are using that?
Great question. Quite honestly, as a developer, I myself have been pretty divided on how to use the confidence score. As I was building this out, my initial approach was, I'm going to have a programmable threshold that the user of the API will say, hey, only return entities, extracted relationships, etc., above a certain threshold. So that's one school of philosophy, but the other philosophy is like, is more information better than less? So should you have all the information with whatever confidence score there is for maybe a human being to make a better decision on how to use that information? So the approach taken now is like, I put the confidence score for whatever it is and let somebody else make a decision, clearly calling out that this is generated from a machine learning entity. But with respect to answering your exact question, like how are users using the confidence score? I don't see a clear pattern on how it is, but the same questions are coming up. And I think it's a matter of trying it out, playing with it enough, and kind of deciding on what people are more comfortable with. But you're right. That comes up. The question comes up, but there isn't. I haven't seen a pattern on what people are deciding to do just yet.
Yeah, makes sense. Thank you.
So I also have 2 questions coming in from the Hoover app. First one is, what human languages does it support beyond English?
Today it's English. I hope that answers
Yes,
it.
it does. Quick answer.
But that said, Google works with. I mean, like, if you have a requirement, come talk to us, and we'll connect you to the right people.
And the other one is the specific device names or medication names mapped to, are they US specific? In other words, can we feed the taxonomy of devices or medications so that the NLP algorithm can map the data to what we feed?
So right now, the mapping to FHIR is based on the linked entities, like I mentioned before. If you do, so this is my approach as a developer again. This is my approach. One is find out what the roadmap is. And I don't have that answer yet. I mean, I can get back to whoever's asking. I'll look it up on Hoover, get back to whoever's asking on supporting extended vocabularies and stuff. But the second thing is, if you have 90% of the job done by this bundle that's created, how hard is it to have a post-processing step to do some mapping? If that, check out if that's feasible, because the bulk is kind of done. Just another thought.
Okay, thank you. Are there any other questions from the audience here? Okay, then thank you for your presentation, and
thank you, everyone.